Started. Good evening, honorable faculty members. Today I'm going to present my work, synthetic data generation with cycle GAN to improve robustness of deep neural networks for COVID-19 detection. This work was done by myself, Rafi Al Mahmoud, with my co-author Ahmed Rafiun Noor. Our contribution in this work was divided in two parts. One was generating synthetic data using CycleGAN and transfer knowledge from MobileNet V2 to ResNet 50 and robust lightweight model for our detection. Now I'm going to pass the floor to my groupmate Rafiun Noor to continue the presentation. Rafiun.
Um, you should turn off your presentation first. Let me present. Okay, thank you. Can you hear me?
Yes.
Okay, you can see my screen, right?
Yes.
Okay. Assalamu alaikum, faculty members. My name is Ahmed Rafinur, and I'm going to continue with our project demonstration right now. So we can see here, let me start with background and problem. So if you start here, COVID-19 became one of the largest health crises in modern history. We all know that the testing was essential, but the main test had big challenges, like it was expensive and not affordable in many areas. It was slow, taking hours or even days for result, and it needed laboratories and skill staff, which were not always available in rural hospitals. On the other hand, chest X-ray images is fast, cheap, and widely available. Almost every hospital has an X-ray machine. So we used this idea and we threw a question that can we use artificial intelligence on chest X-rays to detect COVID-19 quickly and accurately. If we go to the next slide, deep learning models such as CNN work best when we have huge label data sets, which we have. We will show the data set in a moment. But in medical imaging, especially for COVID 19, the data sets are small and unbalanced. And it tends to overfit. It memorizes the training images, but when it sees a new patient X ray, it struggles and makes mistake. In medicine, this is very dangerous. Missing a COVID patient seems more inefficient. I'm going to talk about our literature review about a little. So COVIDNet special CNNs for COVID detection. We can see here in what we have done in this section. Image enhancement methods like CLAHE and GAN-based or GAN-based or GAN-based approaches for generating synthetic data and knowledge distillation in computer vision tasks. So our project, most studies focused on one approach at a time. Our project or novelty is that we combine cycle GAN plus knowledge distillation for COVID-19 detection. And now, if we talk about our data set, we use the Kaggle COVID-19 radiographic data set. We have given this link, also the reference, everything to our project paper. So in our data set right here, what we used firstly, it contained about 1,000 real X-ray images, COVID-19 cases, pneumonia cases, and normal cases. That means no diseases at all. But the dataset was small and unbalanced, so we used CycleGAN to generate 101 synthetic images, making the dataset larger and more balanced. So if we go to the next slide, which is processing and augmentation. Before training, we had to prepare the dataset, obviously. All the images were resized to 2 to 4 into 2 to 4 pixels. Pixel values were normalized. Then we applied data augmentation. We used random rotations, horizontal, vertical flips, brightness and contrast adjustment, and small shifts. To work further. This simulates real world hospital conditions where images can vary due to patient movement or machine differences. Now I'm going to talk about the evaluation metrics, what we use. So for our performance in the code, which we have already given in the paper, but here you can see that we evaluate performance. We use accuracy overall, which gives overall correctness, precision, how many predicted positives are correct, recall or sensitivity, how many actual positives were detected, F1 score, balance between precision and recall, specificity, how many negatives are correctly classified. Now, in medical diagnosis, we all know that recall is very important because missing a COVID patient is riskier than a false alarm. We can see that we have used here our model's confusion matrix, and we use MobileNet V2 real and augmented. My co-author and groupmate will talk about this, but we have added the pictures here so you can get an idea about our output. And the result, we are very our result was very promising. You can see here again in the picture we have compressed it, and now if we compare everything, you can see that MobileNet V2 with augmented data achieved 97.35% accuracy with the best performance. And with our augmentation, the same model, I mean, MobileNet V2 had 92.5%. Simple CNN improved with augmentation but was still weaker. ResNet 50 alone overfit the data, but with knowledge distillation, MobileNet V2 improves significantly. Um, so with this result, we can say that the synthetic data plus knowledge distillation is the winning combination. Now, my co-author and groupmate will continue with this presentation and further explain what we have done with the knowledge distillation and other things. Thank you very much. This was from my side.
So, thank you, Rafil. So,
Let me
there
stop
might,
presenting first. Okay, you're good to go.
there might, you guys might have a question that why synthetic data? So, medical images data set usually have a small amount of data, thousand. In our case, we had like 1,000 images. So, we generated synthetic data which allows us to increase our performance more. So more data means better AI performance. CycleGAN usually uses two generators and two discriminators. Generators creates normal images to COVID images. Then two discriminators that judges if those images are fake or real. So for loss functions, we use adversarial loss, which makes the images realistic. So and cycle loss, we use a cycle that continues like cycle loss to normal images, then normal images to COVID images, and then back to the original. Identity loss usually uses the COVID images and stays the same. We generated 1,001 images for the whole data set. So and now you might have a question that why knowledge distillation. So our teacher was MobileNet V2, which had which had a accuracy of accuracy of 92.5% on the real data set, and on the augmented data set it had 97.35%. So we use the mobile but our ResNet 50 had a overfitting problem in a small data. So we use the MobileNet V2, which is a lightweight model, efficient and strong performer in the imaging data sets, and we use ResNet 50 as a student, and we use cross entropy and teacher soft output scale divergence to improve ResNet 50's performance. Now, the models that we used: MobileNet V2, which is efficient, lightweight, and ResNet 50, which uses deep 50 layer CNN with skip connections, and simple CNN, weak model compared to the MobileNet V2. So for future work, uh, we can implement oh, for future work we can implement implement advanced generative adversarial networks. We can use explainable AI or semi-supervised learning to this project. In conclusion, our work proves that even with limited data, we can make the AI robust and get a good accuracy out of it. Thank you. This was our project demonstration for our machine learning course.